Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
I was the first person to lecture on the first algorithm for processor-to-processor processing and solution of real-world problems. And I was the first person to present a series of step-by-step instructions for solving the toughest problems that the supercomputer attracts. For many years, I helped many research mathematicians, research computational physicists, and research supercomputer scientists, and I helped them to solve difficult problems that they could not solve. None of them even acknowledged me in their grateful thanks list. That lack of acknowledgement is one of many subtle ways the contributions of the black inventor gets discredited. It's one of the ways black inventors get oppressed. It's one of the ways the narrative of black contributions to human knowledge gets erased. After those trials and tribulations, I knew to keep the credit for my discovery of practical parallel processing that occurred on the 4th of July, 1989. Keeping the credit for my invention was simple. First, I refused to immediately teach vector processing supercomputer scientists how to parallel process across an ensemble of 64 binary thousand processors. Second, I only talked to the award committee of the Computer Society of the IEEE that gives the top prize in the field of supercomputing. That supercomputing committee reviewed my discovery of practical parallel processing and did so entirely by interviewing me on the telephone and by long-distance correspondence, and did so without knowing that I was black and African. The way I looked at the computer changed at 8:15 in the morning of July 4, 1989. The breakout moment I discovered that the slowest processors in the world could be harnessed and used to solve the toughest scientific problems in the world, and used to solve them faster than the fastest supercomputer in the world. In the old way, and before my invention, we thought of the supercomputer as computing only one thing at a time, and computing that thing with only one vector processor. In my new way, and after my invention, we think of the supercomputer as computing many things at once, and computing those things with millions upon millions of processors that were identical to each other, that were tightly coupled to each other, and that shared nothing between each other. That is, I experimentally discovered how and why the modern supercomputer must compute in parallel in order to simultaneously solve millions upon millions of the most grand challenging problems arising in physics and mathematics, instead of solving only one grand challenge problem at a time. After my invention, the number of parallel supercomputers exploded. Before my invention, parallel processing was scorned, ridiculed, and rejected as a beautiful theory that lacked an experimental confirmation. To discover or invent the massively parallel supercomputer is to make the impossible to compute possible to compute. Please allow me to do a retrospective on the supercomputer back in 1974 and today. I began supercomputing on June 20, 1974, and as a 19-year-old at 1800 Southwest Campus Way, Corvallis, Oregon, United States. As a 19-year-old supercomputer programmer, I felt like a small boy that was in charge of a big ocean liner that turned slowly. At age 19, I was like a mouse crawling inside the supercomputer. By age 34, I had grown into the lion that was protecting the supercomputer hopeful that will be massively parallel processing across my ensemble of 2 raised to power 16 commodity off-the-shelf processors. The supercomputer is getting bigger each year and now costs the budget of a small nation. One supercomputer costs up to $1.25 billion. If this trend continues, the supercomputer might eventually become as big as planet Earth and as costly as the budget of the United States. The supercomputers that I programmed back in the 1970s and 80s could fit into a small bedroom. When it comes to supercomputing, size matters. Today, the massively parallel supercomputer is such a success story that the modern supercomputer now occupies the space of a soccer field. Supercomputing is a big science project that is at the level of the International Space Station. The fastest supercomputer can be at the level of the ITER project that is built in southern France. ITER is the world's largest fusion experiment that is funded by a consortium of 35 nations. ITER is hoped to prove the feasibility of fusion as a source of energy. ITER stands for International Thermonuclear Experimental Reactor. The fastest supercomputer of the future could cost as much as the super collider that was built by the European Organization for Nuclear Research called CERN. In the 1980s and earlier, the big question in the world of the supercomputer was this: can an ensemble of the slowest processors outperform the fastest supercomputer and change the way we look at a modern computer? I answered that grand challenge question by visualizing my parallel supercomputer not as a computer per se, but as a global network of processors that is an internet de facto. I answered that grand challenge question by discovering the supercomputer's inner map and its email GPS. I discovered how millions upon millions of tightly coupled processors must work together as a whole to solve the toughest problems arising in physics and mathematics. I deciphered the email pathways across 1 binary million email wires. Knowing that email pathway is a mathematical precondition to executing the fastest supercomputer speeds. That supercomputer quest was my expenditure to the outer limits of algebra, to the outer limits of calculus, and to the outer limits of the computer. The new big question in the world of the supercomputer should be, can an ensemble of all the processors in the world be harnessed as one cohesive, seamless, fastest supercomputer and change the way we look at the modern supercomputer? The biggest question in computing is how to invent a cosmic supercomputer that encircles the Earth and that is powered by all the computers on the Earth. You may wonder, what is the answer to that biggest question? My answer is this. If anyone knows the answer to the biggest question in computing, then it wouldn't be an unanswered question. To discover demands that I become reclusive and that I look inwards and go inside and do them with my scientific sixth sense. To discover that my ensemble of 2 raised to power 16 processors is a new internet demands that I visualize the configurations of its 1 binary million bidirectional email wires, and that I visualize my ensemble in the 16th mathematical dimension, and that I look into a deep unseen universe that is at the jagged frontier where physics, mathematics, and supercomputing meets. The reason Nigeria needs far more research scientists than the United States is that the Nigerian scientific discoverer will be drafted as a soldier in Africa's fight against poverty and for humanity's quest for progress.
Insightful and brilliant lecture.